Let me introduce some important points on the limaçons. So for this one, I mentioned about this picture is like you're using a suction cup to pull this side, to pull it to the right-hand side. So if you push harder, so the B is greater than A. That means you have an inner loop. If A equals B, that means this is heart shape we call the cardioid shape. And then if you don't push that hard, make the A is greater than B, so we got a dimple. So this point is going to the left-hand side. So before the cardioid, the heart shape, this point going to here, make a dimple. If A is more than the B, or more greater or greater than B, lot more greater than B, that means we have convex limaçon. So there's no dent here. Okay, the important point here, this point equals A plus B. This point is also A plus B. This point is A plus B. This point is A plus B. Since this is A plus B times cosine theta, so my limaçon, is lying on the polar axis. It's like this shape because it's plus B times cosine theta. If minus B times cosine theta is lying to another side that like this. So 1 minus cosine is the shape like this. So 3 minus 2 cosine theta is like this. And then 2 minus cosine theta is like this, another side. And how about the sine? So if A plus B times sine, the shape is like this, is lying on the theta equals pi over 2. So lying on this side. So if 1 plus sine theta, the heart shape is like this. So like this. I think it's too big because here must be A plus B, need to be 2 at 2. So the shape seems like this. If here is R equals 1 plus sine theta. So I erase this because I don't want to confuse you. So if I have 3 plus 2 sine theta, the shape is like this. Here is sine. If here is sine, the shape is like this. If here is minus sine theta, the shape is like this. And if here's minus sine theta, minus 2 sine theta, the shape is like this. And this one is the same, like 1 minus sine theta, the heart shape is here. And this one, if sine 1 minus 2 sine theta, so the sine theta, the graph looks like this. I think I erased some important information. So this point is always A plus B, and the point here, this intersection is A. Here is A. The distance from 0 to here is A. So here is A, here is A, and that means distance from here to here is A. Distance from here to here is A. And what else? Oh, this point. This point equals absolute value A minus B. So this point, if also equals absolute value A minus B here, since a equals b, so a minus a, that's 0. So this point is 0. And this point is also absolute value of a minus b. Be careful here. I mean r equals absolute value a minus b. From here to here, the distance is absolute value a minus b. That's not means this point in the rectangular system is absolute value a minus b. That's in the polar system. That's the r. And this one is also absolute value a minus b. So you will learn this in the pre-calculus. So I hope this video will be helpful when you're learning pre-cal. So it will save you some times then maybe following semesters. Okay, let's see. Graph r equals 2 plus 2 cosine theta. Because here we mentioned about this is a, so this is b, and this is a plus b cosine theta. So a equals b. That means this is a heart shape, and this is cosine theta. So my heart shape should be lying on the polar axis. So the graph looks like this. Okay, to make sure it's symmetric. So this point is a plus b. So a plus b, 2 plus 2 is 4. And here is 0, and this point is a is 2. And then so we got this shape. We can just plot our graph, plot the point, find the graph. Or you can plot the point. We can test the symmetry first. So if you have the graph, you know this graph is symmetric to the polar axis, because if you see this part is symmetric to the polar axis. So this part and this part, they are symmetric along this axis. And how to test it? So the first step, let's try if we plug in r negative theta to see if it's symmetric to the polar axis. So if I plug it in the equation, the r equals 2 plus 2 cosine negative theta equals 2 plus 2 cosine theta. So this expression and this expression are the same. So I can say symmetric to polar axis. And second one, let's try r pi minus theta. So from the picture, I can tell it's not symmetric to pi over theta equals pi over 2, because this side is this shape and this side is this shape. So it's not symmetric to the pi over 2. But I'm going to try to replace the r and theta in the expression by r pi minus theta. So r equals 2 plus 2 times cosine pi minus theta. So expand it. 2 plus 2 times, so cosine pi cosine theta plus sine pi sine theta sine theta. So this one equals 2 plus 2 times. So what is cosine pi? Cosine pi is -1. So -1 times cosine theta, negative cosine theta. And the sine theta is 0. So this term is 0. So I have 2 minus 2 cosine theta. So this one and this one, they are not the same. So inconclusive. So I can't say that it's not symmetric to theta pi over 2, because the test can't prove for sure it's not symmetric to the theta equals power 2. I can only say that's inconclusive. So the third one, let's try negative r and theta. Negative r theta. So if I plug it in the equation, negative r equals 2 plus 2 cosine theta. So these two expressions, these two equations, they are different. That means inconclusive. Conclusive. So we tested the symmetry, and only the first test works, symmetric to the polar axis. That means if I want to plug in the point, I can choose some special points, or I just graph it because I know the shape, and then some special point, 0, 0, and here is, I can't say this is a 0, 0. I should say this is the pole because I don't know the starting point is here or not. Oh, so how to just say this is a pole. This is the distance from here to here is a plus b. So let's see. If I use the plotting point way, and let's make a table. The first row, that's the theta. Second row is r. So when theta is 0, so 2 plus 2 cosine 0, that's this is 1. So 2 times 1 is 2. So 2 plus 2 is 4. Oh, the first point is here. And then second, I put pi over 6 here. So 2 plus 2 times cosine pi over 6 is 2 plus 2 times square root of 3 over 2. That's 2 plus square root of 3. And then next one, pi over 4. So pi over 4 here. That's 2 plus square root of 2. 2 plus square root of 2. Pi over 3. That's 2 plus 1, because 2 times cosine pi over 3. That's 2 times 1/2. So this is 3. I can continue to find pi over 2. So 2 plus 2 times cosine pi over 2. That cosine pi over 2, that's 0. So this is 2. So can I continue to plot some points? Actually, we have learned that symmetric to the polar axis, that means I just find the half, and then use what to find another half? I can try to plot negative pi over 6, and then it's symmetric to the polar axis. That means the r's value is the same. Only difference is angle's value. That's 2 plus square root of 3. So next one is pi over 4, and then it's 2 plus square root of 2, and then negative pi over 3. That's positive 3, and negative pi over 2. That's 2. So I have 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 points. So let's try a similar question in the homework. Let me see. So maybe number 4, number 5. I don't remember. this one. Oh. Okay, let's see this one. So you can, if for this way, I can plot the point. So I can use this plot of a lot of points because here they have the different equation. I can plot the point, maybe plot 10 points or 6 points, whatever. So more point, and then line them up. That's a heart shape. Or you can just click the cardioid because I know the cardioid. So we know that's a cosine and this is positive. So the shape should be like this, right? And then what's the next step? Placing first point on the highlighted arc. So we know this point must be a plus b. So 5 plus 5 is 10. So it's here. And then second point, I mean, that's a, because do you remember I mentioned about this point is a? So here, from here to here is 5. So oh no, I must click 5. Okay, I click 5. So this way is easier because you don't need to plot a lot of points here, and then the symmetric dots here, and then make a heart shape. Because if you use this way, click the shape first, click here, this point is a plus b, and then we know this intersection is a, so we draw the heart shape. Let's see, check the answer. Yeah. So I think this way is easier. If you don't like to graph the polar curve like this way, you just plot the point, like finding the point here and then plot the point. Okay, next one is roses. So look at these beautiful shapes. They are, we call the roses shape. The shape is r equals a times cosine n theta, or r equals a times sine n theta. We have n here. If here n is an even number, like 2, 4, 6, 8, 10, something. So the petal of the rose is 2 times n. So for example, n equals 2. So there are 4 petals here. If n is 4, we have 8 petals. If n is odd number, like 1, 3, 5, 7, 9, something, 11. So we just have n petals. For example, n equals 3, we have 3 petals. 5, we have 5 petals. And then next one, this is a figure 8 shape. Just like 8 is, so if here is cosine, so the figure 8 form is r squared equals a squared times cosine 2 theta. If here is cosine, the 8 is lying on the polar axis. If here is sine, the figure 8 shape is symmetric to the line theta equals pi over 4. So I know theta equals pi over 4 is a line like this. It's a diagonal line like this. So if here is sine to theta, the shape is symmetric to the line theta equals pi over 4. Like, so symmetric to the line here. This is a straight line. Okay, let's see this example. So graph r equals 5 theta. So this one we mentioned about this one, r equals 5 theta is a spiral. So if I want to graph it, I just plot the points. So, but in your mind, you must know that this shape is kind of like this, going all the way out. And so how to find the exact point? So we can draw a table. The first row, that's for theta, second row for r. So when theta is 0, r is 0 because 5 times 0 is 0. And then pi over 3. So 5 times pi over 3. Oh, no, pi over 3 because we always do pi over 6. So 5 pi over 6. Continue to do pi over 4. That's 5 pi over 4. And then pi over 3. That's 5 pi over 3. And then continue pi over 2. That's 5 pi over 2. So we know that it's not symmetric. It's not symmetric to the polar axis or pi over 2 because you flip it, you do the flippation, it doesn't symmetric at all. That means it's not symmetric because we know the shape of the spiral. And so that means we can't use that the negative angle and then the same r because it's not symmetric to the polar axis. So I continue to plug in more points. So next one, I can try what is that? So based on this one, I add a pi over 6. What is that? So pi over 2 plus pi over 6. So that's 6 at the bottom. And here's 3 plus 1. That's 4 pi over 6. That's 2 pi over 3. Let's put 2 pi over 3 continuously. So that's next point is, so this 1 times 5 is 10 pi over 3. Do I have enough? 1, 2, 3, 4, 5, 6. Maybe just one more. Okay, what are these? So pi over 2 plus pi over 4. That's 3. No, that's 3 pi over 4. So 3 pi over 4 times 5 is 15 pi over 4. So let's plot the point. The first one is 0. Second point, so angle goes first. So angle, for example, this angle is 30 degrees is pi over 6. So is, for example, is here, that's a 5 pi over 6. And then next angle is here. So this value is greater than this way. So next one's pi over 3. It's about it's more than this one. Is about here. So about this. So pi over 2. So angle become here is 5 pi over 2. So this one is 5 pi over 2. And then this angle, and we have 10 pi over 3. It's become bigger. And this one have the bigger r. So it's going like this. So just plot them randomly because I don't have a scaled polar system plane. So you use this way because if you are working on your homework, if you have this similar question, you insert the point. Say maybe they ask you 6 point, you insert 6 point here. Because if theta is bigger, so r is getting bigger. And we have learned that theta is from initial here and then going this way, going this way, going this way, going this way. So after 0 to 2 pi, the theta continue this way, but r is getting bigger. So the shape is like a spiral. Let's see next one. Identify the type of polar curve. So this question in the homework, they provide you the shape. They ask you what's the shape, what's the type of the polar curve. So you see this is a straight line. You just circle that this is a line. And then second one, write the polar equation that represents the given graph. So if we see the vertical line, this is the r equals a over, this is cosine theta. And the a is the intersection here. Because it's a vertical line, so we will have a cosine theta. A equals this. So this is negative, right? 1, 2, 3, 4. So a is negative 4. This one equals negative 4 over cosine theta. So this is the expression for this vertical line. Write a polar equation that represents given graph. Yes, we write to the polar equation that r equals negative 4 over cosine theta. Let's move on. Okay, identify the type of polar curve. So if you see this curve, that's a circle. So you circle the circle. Write a polar equation that represents a given graph. So how to write this? For this shape, we have learned that's r equals a times sine theta. Why I put sine here? Because this circle center at the theta equals pi over 2 axis is on this axis. That means here must be theta. How do you decide the a? A is here. This point is a. The distance from here to here is a. So let's count 1, 2, 3, 4. A equals 4. So r equals 4 sine theta. Is positive or negative? Because here is in the bottom of the graph. That means the a is a negative 4. If on the top or on the top half of the graph, this is positive, but here is in the bottom, that means it's negative. So r equals negative 4 sine theta. So if the graph is lying this way, that's positive a times cosine theta. Here is negative a times cosine theta. On the top is positive a sine theta. Yeah, it's sine theta. So right now we find the graph r equals negative 4 sine theta in the polar equation system. So next example, use the graphing utility, graph the polar equation and describe the graph in rectangular coordinate system. So let's use a calculator to graph this. So let's find the calculator. Look at this one. This is in the polar system. That means our mode must be in polar system. So click mode. And then here is fraction. Here is polar. So click cursor. So highlight the polar, hit enter. We have polar system. Second mode, we quit. And then insert this one in the function y equals something. Click y. So you see here is r. So this is r. R equals 3 divided by, use parentheses, 1 minus sine. Here, click this button for theta. And then close the parentheses, close it again because this parentheses is for the bottom denominator. And then hit graph. Oh, this is a parabola. For the parabola, So let's read the question. What does the question want? Using utility, graph the polar equation and describe the graph in the rectangular coordinate system. So you just describe that this is a parabola. And then how to find the vertex for the parabola. Oh, sorry. The vertex, let's see. So when theta equals 0, I mean the angle is 0, that means the R is this point. So when the theta angle is increasing, so here, 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 so the distance from the origin to this point is R's value. And then keep on going. I mean the R is increasing. R is pi, theta is pi, the R is this point. Oh, not this point. R is here, is from the origin to here, the distance. And so the R from initial to here, that's 2 pi over, what is that? Is that 2 pi over 3? No, 3 pi over 2. From, why is so dark? Let me click enter. Yeah, make it lighter. So from initial to here, this is 3 pi over 2. The angle theta equals 3 pi over 2. And then I got here, that's the vertex of the parabola. And then what is the R from origin to this point? We can plug in theta equals 3 pi over 2. Let's put it in. So theta equals 3 pi over 2. So equals 3, 1 minus sine 3 pi over 2. What is the sine 3 pi over 2? Is that -1? Yes. That's 1 minus -1. That's 3 over 2. That means the distance from here to here is 3 pi over 2. So the vertex, use the polar system, I can write it like 3 pi over 2. This is R. How about the theta? Theta is 3 pi over 2. 3 pi over 2. This is in the polar system. How about in the rectangular coordinate system? So look at the graph. I only described the vertex here in the rectangular coordinate. This point is, that means the x value is 0 and the y's value is -3 pi over 2. Yeah, because I know distance from the origin, to here is 3 pi over 2. That means if here is y's axis, here the value must be -3 pi over 2. The x value is 0. So in the rectangular coordinate system, so I can write some details here. Rectangular, just say system. The point of vertex is -3 pi over 2. -3 pi over 2. I think that's about this question. So I think you have the similar question in your homework. So this question, they gave us the R equals 4 over 3 times cosine t minus sine t. Match the rectangular equation with the polar equation. So how to match this one to the equation in the polar system? So number A. So I can move the bottom one to another side because we have learned that x equals R times sine theta or sine t in this question. y equals, oh, so sorry. This is x cosine. So y equals r times sine t. So if I move this one to another side, it's r times 3 times cosine t plus sine t equals 4. And then I distribute the r, that means 90 equals 4. And we have learned that x equals r times cosine t, y equals r times sine t. So this one is x, 3x plus this is y equals 4. And then, is this a line in algebra class you have learned? Yes, this is a line. I can move the 3x to another side. Y equals negative 3x minus 4. Oh, plus 4, sorry. That means the slope is negative 3, is going down this direction. What is the y-intercept? Y-intercept means make the x equal 0. So y-intercept is x equals 0, y equals 4, because plug in 0 here and get y equals 4. So the graph looks like this. So 0, 0, 4 is here. Because it's y-intercept. How about x-intercept? Let's the y equals 0. And then x equals positive. So x-intercept. So y equals 0. So negative 3x plus 4 equals 0. And then x equals 4 over 3. So this point is 4 over 3. So the graph looks like this. So I think that's all about the chapter 8.2. So if you have any question, please let me know. Have a good day.